Welcome! In this video, I'm going to briefly go over the essentials of hypothesis testing. And in the second part, I will test a claim about a population mean. A hypothesis is simply a claim or statement about a population parameter such as population mean, variance, proportion, and so on. In inferential statistics, we study a sample or samples and use the results to generalize on an entire population or populations. Suppose we make a claim that the average age of all college students in a city is 23, which we write as mu equals 23. Since this hypothesis contains equality, we refer to it as the null hypothesis, represented by H0. The complement or opposite of the null hypothesis is the alternative hypothesis, represented by HA or H1. In this case, the alternative would be that the mean is not equal to 23. We use this hypothesis for two-tailed tests because the alternative basically means that the mean could be less or greater than 23. Suppose instead we want to test if the mean is less than 23. Since this statement does not contain equality, we will assign it to the alternative hypothesis. And the null will be the opposite, that is, the mean is greater or equal to 23. And if we're testing if the mean is greater than 23, that will be the alternative hypothesis, and the null will be mean less or equal to 23. These two are hypotheses for one-tailed tests. This is for a left-tailed test, because the alternative hypothesis has a less than sign. And this is for a right-tailed test because the alternate has a greater than sign. Note that the alternative hypothesis determines the tail of the test. Note also that the alternative hypothesis never contains equality, and the null always contains equality. In fact, some only use equal sign for the null hypothesis. Now, when we conduct hypothesis tests, we're primarily trying to decide whether or not to reject the null hypothesis. If we reject the null hypothesis, we will say we have enough evidence to support the alternative, or to say that the alternative is true. If we don't reject the null hypothesis, we will say we don't have enough evidence to support the alternative. We usually don't say that the alternative is not true. We only say that we don't have enough evidence to support it. Now, to determine when to reject the null hypothesis, we select a significance level alpha. 5% or 0.05 is the most commonly used alpha value. 0.10 and 0.01 are also often used. The significance level helps specify the size of the region where the null hypothesis should be rejected. We call that region the critical or rejection region. For a two-tailed test, alpha is divided by 2 into both tails. So we reject the null hypothesis in the tails and we don't reject it in the middle here. For one-tailed tests, alpha is not divided. So for the left-tailed test, the rejection region is in the left tail. And it's in the right tail for the right-tailed test. Once the rejection region is set, we then calculate the test statistic. If the test statistic falls in the rejection region, we reject the null hypothesis. Otherwise, we fail to reject it. In the second part of this video, we will look at this example to illustrate the hypothesis testing process. Thanks for watching.